Have you ever just stopped for a second and noticed how much stuff is always changing around you? I mean, all the time. Ice melting, a piece of fruit ripening, paper being folded. We're going to dive into what's really going on with all these everyday transformations. You know, it all starts with just noticing something. Like this. A simple observation. Yesterday, it was a bud. Today, it's a flower. A solid piece of ice becomes a puddle of water. But what is actually happening there? What's going on under the surface? And that's really the big question we're going to tackle. Are all these changes basically the same thing, or are there totally different processes at play? We're going to play detective here, and I promise, by the end of this, you'll start to see the world around you a little differently. All right, first up, let's talk about our first type of change. Think of these as the masters of disguise. They're the changes where things look different, maybe even act different, but deep down, they haven't really become something new at all. So let's look at our first clues here. You fold a sheet of paper into a boat. It looks like a boat, but is it still paper? Yep. You inflate a balloon, and sure, it gets bigger, but it's just stretched out rubber. And if you crush a piece of chalk into powder, you just have a bunch of tiny pieces of chalk. The actual stuff hasn't changed its identity. Here's a super simple way to think about it. It's like getting a haircut. You definitely look different, right? But you are still you. The change is just on the surface. And a big clue here is that these changes are often reversible. You can unfold that paper boat right back into a sheet. So there is a name for this. Officially, scientists call it a physical change. It's any change to the physical properties, like its shape, its size, or its state, solid, liquid, or gas, where absolutely no new substance is created. But some changes go way deeper than that. They're not just a disguise. They are a total, fundamental transformation, a brand new creation. Let's look at a classic experiment that gives us the proof we need. You've probably done this. You mix vinegar and baking soda, and what happens? You get that awesome fizzing and bubbling. Well, that fizz is a gas, carbon dioxide, and we can actually prove it's a new substance. If you capture that gas and bubble it through something called lime water, the lime water turns all milky. That's the classic test for CO2. We literally just created something that wasn't there before. The perfect analogy for this is baking a cake. You mix up flour, eggs, and sugar, and then you bake it. That heat transforms everything into, well, a cake. And once it's baked, you can't go back. Good luck trying to unbake a cake and get your eggs and flour back. It's a one-way street. And that, my friends, is what we call a chemical change. It's when the original materials go through something called a chemical reaction, and they get rearranged to form one or more totally new substances with totally new properties. Okay, so let's put them side by side. The bottom line, the one question you have to ask is, was a new substance created? For a physical change, the answer is no. For a chemical change, it's a big yes. And that's also why physical changes are usually reversible, and chemical ones, not so much. And these changes aren't just for a science lab. They're happening all around us in the most beautiful ways. You know if fireflies glow? That's not a tiny light bulb. That is a chemical reaction happening inside its body. It's a process called bioluminescence, an absolutely stunning example of a chemical change right there in nature. Okay, time for a little puzzle. So, we've got our two neat little boxes, right? Physical and chemical. But what happens when something seems to be doing both at the same time? Let's take a closer look at a simple burning candle. So, what do you think? When a candle burns, is that a physical change because the wax is melting, or is it a chemical change because there's a flame and it's giving off light and heat? It's a great little riddle because the answer is it's both. This is such a perfect example of how both can happen at once. First, the solid wax melts into a liquid. That's a physical change, just a change of state. Then, that liquid wax gets drawn up the wick and turns into a gas. That's another physical change. But then, and this is the key part, that wax vapor actually burns in the flame. That is the chemical change, the part creating the light, the heat, and all the new stuff like soot and carbon dioxide. So understanding this difference isn't just, a fun science fact. It's actually critical to understanding pretty much everything, from how we cook our food to how our entire planet works. I mean, chemical changes are everywhere. When you see rust on a car, that's a slow chemical change, turning iron into a new thing, iron oxide. The combustion that powers our cars, that's a super fast chemical change. And literally every single meal you cook is just a delicious series of chemical changes. And speaking of combustion, let's talk about fire. For a fire to exist, you always need three things. It's called the fire triangle. You need fuel, something to burn. You need oxygen, usually from the air. And you need heat, enough to get the whole thing started. Take away just one of those three things, and poof, the fire goes out. A simple rule, but incredibly powerful. And these processes, they scale up, like way up, to a planetary level. Over millions of years, giant rocks get broken down. They get cracked by ice freezing, that's a physical change, but they also get changed by reacting with rain and air, that's a chemical change. This whole process is called weathering, and it's what creates the very soil we depend on. So once you know what to look for, you start seeing it everywhere. The world really is just one giant laboratory. So the next time you see toast browning, or leaves changing color in the fall, or even just water boiling for pasta, ask yourself that question. Is this just a disguise, or is it a whole new creation? What change are you going to spot next?